A horizontal bar AB of length 3 meter and weighing 500 Newton is lying in a trough as shown in figure. Find how close to the end B a load of 600 Newton can be placed safely. So here a bar of 3 meter is placed in between lying in a trough as here is the diagram, and here the weight of the bar is 500 Newton and we will have to find out the 600 Newton can be applied safely at what distance from B. So here first consider the free body diagram of the given problem. So here there are two reactions, one is NB here and another one is FB, and here also it is NA and here it is FA. So here there is a 500 Newton weight of the bar and we'll have to find out the 600 Newton can be placed safely on the bar. So first we will have to find out the reactions at A and B. So here it makes an angle 30 degrees with the horizontal line, and here it makes an angle 60 degrees with the horizontal. So in the same way here also it makes an angle 45 degrees with the horizontal and it makes a 45 degrees with the horizontal. Now consider take moments about B. So here moments about B is equal to first FA sin 60 plus NA sin 30 minus 600 into, let us say it is at a distance of x from the B. So 600x minus 500 into 1.5 is equal to 0. Now but first we will have to find out the FA and NA. Here both are the reactions at the point A. So here consider sum of the algebraical vertical forces are equal to 0. So from this equation it is FA, it is FA sin 60 plus NA sin 30 plus NB sin 45 minus FB sin 45 is equal to sum of the downward forces, that is 600 plus 500, it is 1100 newtons. But we know that here FA is equal to mu NA and FB is equal to mu NB, and mu is given by 0.2, so it is equal to 0.2 NB and FA equal to 0.2 NA, and like that consider sigma h is equal to 0, which gives a value of FA cos 30, which is minus, plus NA cos 30, FA cos 60, NA cos 30 minus NB cos 45 minus FB cos 45 is equal to 0. So here it is plus FB cos 45 is equal to 0, and here also substitute FA is equal to mu NA and FB is equal to mu NB, and from these two equations we can get the values of FA and NA, and these values are equal to, here FA is equal to nearly 186 newtons and NA is equal to nearly 929 newtons. And now substitute all these values in momentum equation. So from this equation you can find out x, and x is equal to 1.877 meters from B. So in the options, the right option is C. C is the right answer. A simply supported beam has a span of 4 meter and a rectangular cross section 100 mm into 200 mm. Find the uniformly distributed load it can carry if the maximum bending stress and the maximum shear stress are not to exceed 10 Newton per mm square and 0.6 Newton per mm square respectively. So here we have two constants. One is from shear stress and another is from bending stress. So first we will have to find out the maximum bending stress and maximum shear stress induced in the member, and uh, then we can find out the maximum load can be carried by simply supported beam. Here in a simply supported beam, the maximum shear force is equal to WL by 2. So here it is W into 4 by 2. Here the span of the beam is 4 meters, so that it is equal to 2W, that is 6 kilonewton. And maximum bending moment induced in the beam is equal to WL square by 8. It is equal to W into 4 square by 8, which is equal to 2W kilonewton meter. So these are the maximum bending stress and maximum shear force induced in the beams. So that here we'll have to find out the W, the value of W, that is the load per meter. So from the maximum bending stress, from the point of view from maximum bending stress, here the maximum bending stress induced in the beam is equal to sigma max is given by m into z, and it is not to exceed 10 Newton per mm square. Here m is equal to 2W into z is BD square by 6 is equal to 10, and here 2W into 100 into 200 square by 6 which is equal to 10. So from this equation we can find out W, that is equal to 3.33 and nearly 3.34 kilonewton per meter. So this is one option. And from the maximum shear stress point of view, from maximum shear stress, the maximum shear stress is given in a beam is equal to 1.5 into F by BD and is not to exceed 0.6 Newton per mm square. So from this point it is equal to 1.5 into F is 2W by BD 100 into 200 and is equal to 0.6. From this we can have W is equal to 45 kilonewton per meter. So in the option, the right option is B. B is the right answer.